I welcome you all, dear students. We are uh, starting new topic, that is electromagnetism, and this chapter. And during these lectures, we will study about techniques which are used to solve some of the electromagnetism, and we will see what are the situations, the problems where we can use techniques to solve some of the problems. Now here it is. At what the distance from a long straight wire carrying a current 10 ampere in the magnetic field is equal to Earth magnetic field of 5 multiplied 10 to the power minus 5 Tesla. So this is the problem. If you look at, here it is. At what the distance from the long straight wire carrying a current of 10 ampere uh, is 10 ampere is the magnetic field is equal to Earth magnetic field of 5 multiplied 10 to the power minus 5 Tesla. So here it is. This is the amount of the current, that is 10 ampere, and magnetic field strength of the value is 5 multiplied 10 to the power minus 5 Tesla. You know the value of the permittivity, that is the 4 pi mu naught value, that is 4 pi multiplied 10 to the power minus 7 webers per ampere meter. So if you look at, this is basically formula which is used to calculate the strength of the field. So R, you are supposed asked to calculate the value of the R. Here is the formula. If you look at this, R is equal to mu naught I divided by 2 pi B, strength of the magnetic field, and after putting value, the value of the mu naught is given, that is 4 pi multiplied times to the power minus 7, value of the pi is 3.14, and I, the current is 10 ampere, value of pi again, that is 3.14, multiply the value of the V after putting values. So the value of the R you are calculating, that is R is equal to 4 multiplied times 1 minus 4. So here is the distance, and this will be the distance. So this is the technique which is used to calculate the distance through which you at what the distance from a long straight wire, a current of 10 ampere, and the magnetic field is equal to the Earth's magnetic field, and this is the value. Rest of all the values are given. So you are asked to calculate the distance. So you have calculated by using this formula, which is equal to mu naught I divided by 2 pi R. So here is the next problem. If you look at the solenoid, a solenoid having 1000 turns uniformly distributed over a length of 0.5 meter produces a magnetic field 2.5 multiplied 10 to the power minus 3 Tesla at the center. Find the current in the solenoid. You are asked to calculate the current in the solenoid. First of all, what's given? Number of turns are given. That is 1000 number of the turns. Length of the solenoid, that is 0.5 meter. Magnetic field, it is given 2.5 multiplied 10 to the power minus 3 Tesla, and you know this is the value of the mu naught, and it is 4 pi multiplied 10 to the power minus 7. You are asked to calculate the current. To calculate the current, you have formula B is equal to mu naught Ni, and N is basically number of turns per unit length. Number of turns per unit, you need to know the number of turns, and you know the length of that solenoid, then you can calculate value of N. This is basically number of turns per unit length. So after putting values, rest of all values are given. So here it is I, then by using this formula, you can calculate the current. And This I is equal to BL. This value of the B is given in the data, and L length of the solenoid is also given. Mu naught is also given. So if you look at this is basically 1000 number of the terms. So after putting values, you got 2.5 multiplied 10 to the power minus 3 multiply zero point 0.5 divided by 4 multiply 3.14 multiplied 10 to the power minus 7, and again you are multiplying with 1000, and after multiplication and simplification, what you got the value of the current, and this value of the current is equal to 0.995 multiplied 10 to the power 1, and it is 0.995 ampere, which is equal to 1 ampere, approximately 1 ampere. And the value of the current which you are asked to calculate, that is 1 ampere. So by using this technique, you have calculated basically the current flowing through the solenoid. What was the question? If you look back from the starting, the question is a long solenoid have 1000 turns uniformly distributed over a length of 0.5 meter, produces a magnetic field of 2.5 Tesla, 2.5 multiplied to the power minus 3 Tesla. At the center, find the current in the solenoid. If in such a case, if you know the length of the solenoid, you know the number of turns of the solenoid, you know the magnetic field strength of the through the solenoid, then it becomes more easier for you to calculate the amount of the current passing at that time. So which formula you will use? This is basically formula which is used to calculate, and it is B is equal to mu naught Ni, and you know the value of the N is given. Mu naught already you know the value of mu naught. So the length of the solenoid is also given. The current passing through the solenoid you can calculate if rest of all the values are known. If you look at rest of all the values are known, you know the value of the B, you know value of the N, you know the value of the length, and similarly you know mu naught. So if you look at after putting the values in this formula, you are calculating basically value of the current, and after putting all the values in the formula, that is value of B, value of the length of the solenoid, a number of turns of the solenoid. So if you put the values, uh, you know the value of the pi is 3.14 multiplied by 7, and here the number of turns are 1000. You can already use a technique by putting the value of number of turns to calculate per unit length. Then you can use these number of turns in this formula as well. It will be more simpler. So if you follow these steps, then it's not difficult. It's more easier for you to calculate the current passing through the solenoid. With this, I thank you very much. I hope you people have understood.